Talking about the last section of Unit 3, which is 3F, solving quadratic equations using the quadratic formula. Mine is going to start on page 31. So we're doing 3F. And let's first understand what the quadratic formula is. It is a formula that can be used to solve any quadratic equation. Of course, we can solve using factoring or by taking the square root. And when we solve the quadratic formula and it works for everything, it is kind of hard to remember sometimes. So that's why it's important to solve some of our equations in other methods. When we solve the quadratic formula, as mentioned in our last section, we're going to use the discriminant to determine the number of solutions first, because the discriminant actually appears in the quadratic formula. So we've already learned about half of what we're going to do. The quadratic formula is the following. X is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. As you notice, it is set equal to x. That means we are solving for a missing value. So when we solve this, we need to put our final answer as x equals. And as a reminder, there's that discriminant b squared minus 4ac that we did in the last section. And this 2a is actually underneath the entire problem. So when we divide, we're dividing by the whole thing. There are 3 steps that we want to do in order to use the quadratic formula. And the first step is to make sure that our equation is in standard form. That's ax squared plus or minus bx plus or minus c is equal to 0. In other words, get everything to the same side so that it's equal to 0. Step 2 is to identify a, b, and c and substitute them into the formula. And our last step is to simplify in order to solve for x. So we're going to take a look at a couple of examples where we're using the quadratic formula. So our first example that we are going to take a look at today is going to be x squared minus 9x plus 21 is equal to 0. It's already in the form that I need it in, so that helps. Remember that we want to identify a, which is going to be 1, b is negative 9, and c is a positive 21. So our formula from up here says that x is equal to, this negative sign in front means the opposite of b. So if it's negative, it changes it to a positive. Plus or minus the square root of b squared. Remember, if b is negative, we put it in parentheses. 9 squared minus 4 times 1 times 21. And that's all over top of 2 times 1. Okay, let's just take a look at our discriminant here. In this case, remember that that's b squared minus 4ac. Our discriminant is going to give us some information. So negative 9 squared minus 4 times 1 times 21. So 9 squared is 81 minus 4 times 1 times 21 is 84. And so D in this case is actually going to be a negative 3, which tells me that I'm going to have 2 non-real solutions. So I still want to solve this, but I know that my answer is going to be 2 non-real solutions. So as we solve this, we do it step by step. We haven't used the 9, but we do know that the inside is going to be the square root of negative 3, and under this is going to be a 2. And because we have the negative here, we can leave it in this form and say that we have 2 non-real solutions for this example. Let's take a look at a couple more examples. So example 2 is going to be negative 2x squared plus 144 is equal to 0. Remember, we want to start out by finding our a, which is negative 2. In this case, our b doesn't exist, so it's 0, and our c is 144. Let's go ahead and find our discriminant of b squared minus 4ac. And so we have 0 squared minus 4 times negative 2 times 144. So we have 0, negative 4 times negative 2 times 144 is a positive 1,152. And so D is equal to 1,152. And if we take the square root of that, just to see what type of solutions we have, you can see that it's a decimal, which is an irrational value. So I'm going to have 2 decimal answers for my solution. So let's go ahead and let's check our solutions. X is equal to the opposite of b. Well, it's a 0 plus or minus the square root of 1,152, all divided by 2 times negative 2, so 2a. As a reminder, we'll put up here that we are doing the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. So we have that on each page. And so we will continue with our example. 0 plus or minus the square root of 1152 divided by negative 4. And since there's a 0 here, we can actually just drop that and say that x is equal to plus or minus the square root of 1152 divided by negative 4. And we can actually calculate that. So we're going to take the square root of 1,152 and divide that by negative 4. And so one of my answers is negative 8.485, and we're going to use approximation symbols. And my other answer, we're going to do the negative square root divided by negative 4. And so it will be the positive of that. Again, approximation. And so we have our 2 real but irrational solutions. And we'll do one more example. Our last example is going to be the equation 3x squared minus 22x plus 7 equals 0. So let's go ahead and take out our a, which is 3, our b, which is negative 22, and our c, which is 7. And I'm going to go ahead and calculate our d value. B squared minus, 4ac. And so we have negative 22 squared minus 4 times 3 times 7. So negative 22 squared is 484. 4 times 3 times 7 minus 84, which leaves us with 400. And 400 is actually a perfect square. The square root of 400 is in fact 20, and so we know that we have 2 real rational roots, so they're going to give us some solid answers here. So x is equal to the opposite of b, so we're going to turn that into a positive 22, plus or minus the square root of 400 divided by 2 times 3. So x is equal to 22 plus or minus the square root of 400 divided by 6. And let's go ahead and take the square root of 400. 22 plus or minus the square root of 400 was 20. And so what we're going to do in this case is we're actually going to separate this, and we're going to say 22 plus 20 divided by 6 and 22 minus 20 divided by 6. That's what that plus or minus means. And so this is going to give us x is equal to 42 divided by 6, which is actually 7. And x is equal to 22 minus 20 is 2, 6, and that is actually going to be 1/3. And so we have 2 real rational roots. We will do some more practice with the quadratic formula and using our discriminant in class.